Today we are going to be talking about volumes of prisms. Now, volume is very closely related to area. When we were talking about our two-dimensional figures like squares, rectangles, parallelograms, trapezoids, triangles, things like that, we started by just counting the number of squares on a coordinate plane. Like we drew a figure and we counted, and then we eventually learned a formula to help us. Same thing is true with three-dimensional figures like prisms. So say we have this prism here. It has the base of a square. Now, this is a rectangular prism because a square is a type of rectangle. So what we are doing now is we're trying to figure out how many cubic units. So I have, let's get a little closer, sugar cubes. Please do not eat the sugar cubes. We are trying to figure out how many of these cubes can fill this space occupied by this prism. Same thing is true with this particular rectangular prism. All right, so just for instance, if I put 4 cubes together, one layer is 4 cubes. If I did another square, put 4 together, put it on top of that, okay, so I now have a prism. Remember, a prism has 2 parallel bases, and it has polygons as faces. Same thing is true. We have to kind of use our imagination here. So I have 2 cubes by 2 cubes on the bottom layer, and then I have 2 layers. So what I can say is I have 4 cubes. 2 times 2 is 4, and then I have 2 layers. 4 times 2 is 8 cubic units. So if we took this apart and we actually counted, yes, we do have 8 cubes. What if I put another layer on? So I have 4 more cubes. So now I have a prism. It's 2 by 2 on the bottom, on the base, and I have 3 layers. So 2 times 2 on the bottom is 4 on each layer, times 3 layers. 4 times 3 is 12. We would say that this prism is 12 cubic units. So the general formula for the volume of a prism is base times height. Where have you heard that before? Base times height. Yeah, with some of our two-dimensional shapes. Base times height. Let me take you to the board. All right. So volume equals base times height, B times H. Now look at that. The B is capital now. Remember I said every letter, if it's lowercase or capital, it has a meaning. So when you see a capital B in an equation, when it has to do with volume, this means the area of the base. So this is the area. In other words, how much is on the bottom layer. And H is our height. So let's take, for instance, this rectangular prism, and I did my best for drawing this. I have a 4 by 4 square on the bottom, and my height is 10 centimeters. So first I'm going to calculate the base. What's the area of the base? Base is 4 times 4, which is 16. Then I'm going to multiply it by the height. So we could say the volume is equal times the base times the height. The base is 16, the height is 10. Therefore, my volume is 160 cubic centimeters. Cubic, we have a 3, cube, and I think of the 3 as 3-dimensional. If we're talking volume, we're 3-dimensional, cubic centimeters. Another way we could look at that as well, let's just say volume equals length times width times height. So we would say the length and the width of the base, 4 times 4 times 10, and that is equal to the 160 cubic centimeters. Now, as you know, rectangular prisms is not the only kind of prism that we have. We could have a triangular prism. We do the same thing. Volume equals base, capital B, times the height. So in this case, we have a triangular prism. It kind of looks like that, a different kind of triangle, but we have bases of triangles, and then we have how high it is along this one edge. In this case, we have 4 by 6. That's my base and my height of my triangle. Now we have to use the formula for the area of a triangle. 1/2 base times height. We're using all these base times height base. It's so confusing. All right. So the base is 1/2 lowercase b times h, and that refers to this triangle. So it's 1/2 times 4 times 6. This becomes 4 times 6 is 24. Half of that is 12. So my base is 12. And then I multiply it by the height, which is the length of one of these edges on the rectangle. So volume equals 12 times 8, which is 96 cubic centimeters. Might be a little bit hard to visualize on a triangular prism, kind of like it was to find the area of an actual triangle. You had to count kind of partial squares in order to find out the square unit. We are kind of figuring out partial cubes to find out the actual volume. So that is how you find the volume of